The closest object in space to Earth is the Moon, floating about 384,400 kilometers away. That's roughly the same distance as traveling around the Earth 10 times, and yet, for most of human history, we had never set foot on it. Despite the distance, we learned about the Moon's surface, its craters, and even its past, just by studying it from here on Earth. Now, scientists have discovered planets far beyond our solar system, and they've never even seen them directly. How is that possible? How do we know about distant worlds orbiting stars we can barely glimpse? How can we map invisible belts of ice beyond Neptune? How did we even prove black holes exist when, by definition, they can't be seen? The answer is simple but extraordinary. We don't just observe, we infer. By watching tiny movements, slight changes in light, and invisible gravitational tugs, humanity has built a picture of a universe we cannot touch, and may never touch. This is a story of curiosity, patience, and the amazing human power to imagine the unseen. Long before modern science, ancient people looked up at the night sky and wondered what was out there. Without telescopes, they relied only on their eyes, their memories, and simple math to make sense of the stars. The Babylonians, over 3,000 years ago, were some of the first to record the positions of stars. They drew detailed star maps on clay tablets and even predicted events like eclipses. To them, the sky was a clock and a calendar, guiding farming, festivals, and daily life. The ancient Greeks took things even further. Thinkers like Aristotle and Ptolemy developed models of the universe, trying to explain how everything moved. They believed Earth was at the center of everything, and the stars and planets moved around us in perfect circles. They didn't get everything right, but their ideas shaped science for centuries. Across the world, the Mayans also watched the sky closely. In the jungles of Central America, they built huge observatories and created calendars more accurate than some used in Europe at the time. Their deep understanding of the heavens helped them plan crops, rituals, and even predict solar eclipses. One thing all these ancient cultures noticed was that while most stars stayed fixed in their places, a few wandered across the sky. These were the planets, and they moved in strange, looping paths compared to the steady background of stars. These wandering stars fascinated ancient astronomers and made them realize the sky was more complicated than it first appeared. At its core, early astronomy was about two powerful human tools: observation and patterns. By carefully watching the sky night after night, and by spotting patterns over time, ancient people began to unlock the secrets of the cosmos without ever needing modern technology. Their passion for the stars set the foundation for everything we know today. It proves that you don't always need high-tech tools to make incredible discoveries, just curiosity, patience, and a keen eye for the patterns written across the sky. In the 1700s and 1800s, the first telescopes were getting better. For the first time, humans could see farther than ever before. One big discovery during this time was Uranus. It was the first planet found with a telescope, and it proved that the solar system was even bigger than people had thought. But soon after, astronomers noticed something strange. Uranus wasn't moving exactly the way it should. It was drifting off its predicted path, just a little, but enough to make scientists scratch their heads. Was it a mistake? Or was something else pulling on it? Some scientists believe there must be another planet out there, tugging on Uranus with its gravity. Even though they couldn't see this new planet, they could feel its presence through Uranus's strange motion. Using only math and the laws of gravity, astronomers calculated where the hidden planet should be. It was like trying to guess where an invisible ship is by looking at the waves it leaves behind. In 1846, their hard work paid off. A French mathematician named Urbain Le Verrier and a British mathematician named John Couch-Adams both predicted the location. When astronomers pointed their telescopes in that direction, there it was, Neptune. Another new world, found not by sight, but by thinking, predicting, and trusting the invisible clues. This was one of the first great moments of indirect discovery, finding something without seeing it first. It showed that the universe leaves fingerprints everywhere if we're smart enough to notice them. When we imagine discovering new planets, we often think about pointing a giant telescope at the sky and simply spotting them. But in reality, finding new worlds almost never works like that. Instead, scientists use indirect methods, techniques that help us find planets without actually seeing them. One of the most powerful techniques is called the transit method. Here's how it works. When a planet passes in front of its star, it blocks a tiny bit of the star's light. This causes the star to look just a little dimmer, like someone flicking a light switch very slightly. Telescopes like Kepler watch thousands of stars at once, searching for these tiny dips in brightness. Thanks to this method, Kepler discovered over 1,000 exoplanets across the galaxy, all by simply noticing small shadows. Another important method is radial velocity, sometimes called the wobble method. When a planet orbits a star, it doesn't just circle the star actually moves slightly too, pulled by the planet's gravity. By looking closely at the light from a star, scientists can detect tiny wobbles, like a cosmic dance. This wobble tells us there's something out there, even if we can't see it directly. Then there's gravitational microlensing. This is a little stranger. When a planet and its star pass in front of a background star, their gravity can bend the light, acting like a giant magnifying glass. If a planet is there, it creates a small but noticeable extra bump in the brightening. Microlensing is rare and tricky to catch, but when it happens, it can reveal planets far, far from Earth. You might wonder, why don't we just take pictures of these planets? The truth is, direct imaging is incredibly difficult. Planets are tiny compared to stars, and the stars are so bright that they overwhelm the dim planets next to them. It's like trying to photograph a firefly sitting next to a lighthouse from across the ocean. The amazing reality is, most planets we know about have never been seen. They were discovered through tiny clues, small changes in light, tiny wobbles in stars, and invisible fingerprints left across the cosmos. Sometimes in space, the things we can't see are the most exciting. Take the Kuiper Belt, for example. Astronomers noticed that some objects beyond Neptune weren't behaving like they should. Their orbits were strange, stretched out, tilted oddly. It was as if something unseen was pulling on them. This clue led to the discovery of the Kuiper Belt, a huge ring of icy objects circling the Sun, far beyond the planets we knew. But even now, there's a deeper mystery. Some scientists believe that something even bigger is hiding out there, something we call Planet 9. We've never seen it. We don't have a photo. But the way certain Kuiper Belt objects move suggests that a massive planet could be lurking in the darkness, pulling on them with its gravity. It's like spotting ripples in a pond and knowing something big must have made them, even if you can't see it. This method of finding things we can't directly see isn't new. Long before we ever captured the first image of a black hole, scientists knew black holes existed. They watched stars orbit around invisible points. They noticed strange X-rays blasting from empty-looking space. These were signs, hints that something massive, but unseen, was there. It's a bit like being a cosmic detective. You don't always find the clues you expect. Sometimes you notice a wobble, a dimming, a tug, and from these tiny hints, you piece together something extraordinary. In space exploration, inference, the ability to guess what's out there based on what we can observe, is just as important as seeing things with our eyes. Many of the most important discoveries in space started with a mystery, a suspicion, a feeling that something's not right. And that's what makes space so thrilling. It's not just what we know that keeps us looking up at the stars. It's what we don't know. The secret's still hiding in the dark, waiting for us to notice a ripple, a shadow, a whisper across the cosmic sea. humanity's greatest discoveries didn't happen overnight. In fact, the story of Neptune shows just how patient scientists must be. When astronomers noticed that Uranus was wobbling strangely in its orbit, they didn't immediately see the cause. Instead, they made a bold guess: another planet must be out there, tugging on it with its gravity. They did the math, pointed their telescopes, and eventually, they found Neptune. But from the first strange observation to actual confirmation, it took decades. The same is true for planets beyond our solar system. Scientists talked about exoplanets, planets orbiting other stars, long before we ever found one. It wasn't until the 1990s that the first confirmed exoplanet discovery made headlines. Before that, all we had were theories, hope, and determination. Space exploration demands incredible patience. Think about it. The Hubble Space Telescope, launched in 1990, spent years adjusting and observing before it gave us the incredible deep space images we now treasure. The New Horizons mission took nearly a decade just to reach Pluto, and it kept going, traveling deeper into the Kuiper Belt. And today, the James Webb Space Telescope peers even farther into the universe's past, a dream made real after 20 years of planning, building, and testing. Science moves slowly because the universe is vast and unforgiving. Instruments must be perfect. Calculations must be exact. And sometimes, you have to wait and wait for the right alignment, the right light, the right moment to see something incredible. But every new discovery, no matter how small, reshapes our understanding of everything. Maybe that's why our curiosity never stops. It pushes us to build better telescopes, to launch daring missions, and to spend lifetimes chasing answers. As the old saying goes, curiosity is humanity's most powerful rocket fuel. We don't give up when the answers are hard to find. We keep reaching further into the dark, knowing that somewhere, out there, something amazing is waiting to be found. And that spirit, that relentless curiosity, might just be the reason we'll one day step onto worlds we can't even imagine today. We don't always find new worlds by seeing them with our eyes. Instead, we discover them by following tiny clues, like a small wobble, a faint dip in light, or a strange tug in a planet's orbit. We find planets by their whispers, not their faces. Throughout history, this method of listening to space has led to some of the greatest discoveries ever made. From Neptune's hidden dance behind Uranus to the many exoplanets we've found light years away, we've proven something incredible. Even without stepping outside our solar system, we can unlock the secrets of the universe. And we're just getting started. New tools are coming, gravitational wave observatories that can detect ripples in the fabric of space itself. Next-generation telescopes, like the James Webb Space Telescope, will peer deeper than ever before. And maybe one day, quantum sensors will let us see the invisible with shocking precision. The future of space discovery won't just be about traveling far. It'll be about thinking bigger, listening closer, and understanding more than ever before. Because in the vast darkness between the stars, our minds see farther than our eyes ever could. Stay curious. Stay inspired. The universe is still whispering its secrets to those who dare to listen.